So let's talk about building massive software applications. Imagine you're in charge of a huge construction project. You've got two choices. You could build one single giant skyscraper with absolutely everything under one roof, or you could build an entire city, a sprawling metropolis of smaller, specialized buildings that all have to work together. Well, that second option, that's the world of microservices. And today, we're going to walk through the complete blueprint for building your very own city of services. Here's the game plan. We're going to start with the main blueprint, then we'll lay the foundation, figure out how to connect all the services, and then tackle the really important stuff like security, keeping the lights on, and even how to build for compliance in those super regulated industries. You know, every great construction project starts with one fundamental choice. Before you even think about laying a single brick, you have to decide on your architectural style. And in the world of software, that means choosing between two very, very different philosophies.
And here they are, side by side. On the left, you've got the monolith. That's our giant skyscraper. Every single feature, from the front desk in the lobby to the fancy penthouse suite, it's all part of one massive structure. But on the right, you've got microservices, our city. Here, every feature, the bank, the post office, the hospital, is its own independent building. It's a completely separate deployable service. And this right here, this is the crucial decision you have to make right at the start.
Okay, so you've decided to build a city? Awesome. But hold on, you can't just start throwing up buildings all over the place. The very next, and maybe most important step, is to get out your drafting table and draw a really detailed map of your city. You've got to define all your districts and property lines with serious care. And this whole mapping thing, it really just boils down to two key steps. First, you have to figure out the purpose of each area in your city. These are what we call your business domains. Then, once you know what they do, you draw the lines on the map that officially separate them. You define the service boundaries. Now, to do this properly, we use this really powerful idea called bounded context. It sounds technical, but it's just the formal way we map out the districts of our city. So, for example, in a healthcare app, you'd have your patient district, a billing district, and an appointment district. Each one has a crystal clear purpose and a hard line boundary around it. Now, here's the really crucial part about those boundaries. Each building, each service in your city has to be totally self-sufficient. It owns all of its own private records, there's no shared central library that everybody uses, and it only talks to the outside world through its designated front doors, its APIs. This is what gives you the biggest benefit of all. You can completely renovate or even rebuild one building without shutting down the entire city. All right, so our districts are planned, the buildings are sketched out. Now we hit the next big challenge for any city planner. How in the world do we connect everything? We need roads, we need power lines, we need communication systems so all these independent parts can actually work together. Which brings us to this very simple but incredibly important question. If the billing service over in the financial district needs information from the patient service in the medical district, how does that message get from one building to the other? Turns out there are two main ways to do it. Synchronous communication, that's like a direct phone call. The billing service calls the patient service and literally waits on the line for an immediate answer. It's great when you need something right now. But then there's asynchronous. This is more like a super reliable postal service. The billing service just drops a message into a message queue, and the patient service picks it up and deals with it whenever it's ready. This approach is fantastic for making your whole city more resilient. And that brings up the elephant in the room. In a complex city with so many moving parts, things are going to break. It's inevitable. So if one building has a sudden power outage, how do you stop it from causing a citywide blackout? This is where you design in some safety systems. A circuit breaker is like an automatic switch that stops sending traffic down a road the second it gets blocked. Retries and timeouts are like redialing a busy phone number a couple of times, but then giving up instead of waiting on hold forever. Health checks are like your city inspectors, constantly walking around and checking that each building is up and running. And to see it all, you have a central monitoring room. That's your centralized logging, giving you a perfect bird's-eye view of everything happening across the entire city. Okay, our city is planned, it's connected, and it's resilient. Now it's time to get practical. We need to talk about securing every single building and figuring out an efficient way to deliver new materials and upgrades. First things first, security is not an optional extra. It is a non-negotiable requirement for every single service. Authentication is all about checking an ID at the door, proving you are who you say you are. Authorization is about what you're allowed to do once you're inside, like a keycard that only opens specific doors. And encryption makes sure that any messages sent between buildings or any data stored inside them is completely unreadable to anyone who shouldn't be seeing it. So what about deployment? How do we get things built? Well, think of this modern tech stack as an automated, super efficient logistics system for your city. CI/CD pipelines are your automated delivery routes. Docker containers are the standardized shipping containers that can hold anything. And Kubernetes? That's the master traffic controller and crane operator, making absolutely sure that every container gets to the right building and is installed perfectly, without disrupting any other part of the city. So, our city is built, connected, and secure. But the job isn't over, not even close. A city is a living, breathing thing. Now comes the ongoing task of managing the day-to-day flow of data, traffic, and growth. You know, one of the trickiest parts of managing a whole city of services is the data. Trying to make sure that every single database and every single building is updated at the exact same millisecond, well, it's nearly impossible and it's incredibly fragile. That's a distributed transaction. The much, much better way is something called eventual consistency. It's kind of like sending out a citywide memo. Everyone will eventually get the update and be in sync, but it doesn't have to happen instantly. It's just a far more resilient way to operate. So, managing the city day to day means you're always keeping an eye on things with monitoring tools. But here's the real magic: scaling. Let's say the financial district gets absolutely slammed with traffic during trading hours. You don't have to build a whole new, bigger city. Nope. You just add more capacity to that one district, scaling it horizontally, and then you can scale it right back down when things get quiet. It's just unbelievably efficient. All right, let's wrap up with a bonus topic. What if you're not just building any city? What if you're building in a highly regulated district? I'm talking about a hospital complex or a federal banking center. The rules here are way, way stricter. In these special districts, every single service needs extra features baked right in. Think of it like installing security cameras and detailed entry logs in every single room. That's your audit logging. You need much stricter access controls, and each service has to know exactly how long to keep records before securely destroying them to comply with laws like GDPR or HIPAA. Microservices can actually make this easier because you can isolate all that sensitive logic inside one highly secure, specialized building. So after this whole journey, let's bring it back to the core reason we'd even consider building a city instead of a skyscraper. It all comes down to one word: decoupling. Breaking things apart gives you agility, so you can change and adapt faster. It gives you scalability, so you can grow smarter. And it gives you fault isolation, so one little problem doesn't bring the whole system crashing down. And that leaves us with the final and honestly the most important question of all. You have the blueprint now. You get the complexity, you see the trade-offs, and you understand the power of building a city of services. But let's be real, building and managing a city is a massive undertaking. So the question you have to ask yourself is this: is the problem you're trying to solve big enough to actually need a city? Or would a single, magnificent, well-designed skyscraper serve you better? The answer, well, that depends entirely on you.